Now what we need to know about wavelengths is that longer wavelengths will have lower frequency. A trick to remember this is L and L. Now to explain this, a wavelength is from crest to crest. So this right here would be one wavelength. Now if you look at this down here, from crest to crest, there's three of them. Now the definition for frequency is number of passing wavelengths per second. So if in 1 second this one had one wavelength and this one had 1, 2, and 3, this one down here would have a higher frequency. So higher frequency has a shorter wavelength. So it's a shorter wavelength, that means it's a higher frequency. This one here, it's a longer wavelength, so that means it has a lower frequency. Lower because the number of passing wavelengths per second will be lower compared to this, which will be more higher. Now this here is the electromagnetic spectrum. It goes from the left, radio waves, infrared rays, visible light, ultraviolet, X-rays, and gamma rays. Visible light is broken down into roygbv. R stands for red, O is orange, Y is yellow, G is green, B is blue, and V is violet. Now the farther you go to the right, the frequency is going to increase and the wavelength is going to shorten. So for violet, violet is going to have the shortest wavelength because it's farthest to the right. Now what you're going to need to know about radio waves is they have the longest wavelength and the lowest frequency. That's because they're all the way to the left side. And to the right side, the farthest to the right side on the electromagnetic spectrum is the gamma rays, and they have the shortest wavelength and the highest frequency.